Assalamualaikum warahmatullahi wabarakatuh. The Honorable the Dean of Faculty of Mathematics and Natural Sciences, Universitas Negeri Semarang, Profesor Edi Cahyono, the Honorable Professor Wong Kun Lee and Professor Kwang Hong Jung from SOGANG University of the South Korea, the Honorable Professor Asep Kaderohman and Dr. Tuzi Widianti from Universitas Pendidikan Indonesia, the Honorable Professor Dr. I Gusti Lanang Wiratma from Universitas Pendidikan Ganesha. All Vice Deans in the Faculty of Mathematics and Natural Sciences, lecturers, students, and all distinguished participants. Good morning, and I would like to welcome you all to the seminar on research trends in chemistry and chemistry educations. I'm Grindra Putri, acting as your master of ceremony. Thank you very much for coming to this event. And in order to start these occasions and also for our first agenda, please you all can all rise and let us sing our national anthem Indonesia Raya and also our university march, Mars UNNES. Ladies and gentlemen, please all rise.
Majulah universitas
In order to welcome all audience, let me invite Professor Dr. Sutikno MD, the Vice Dean for Partnership and Research, as the representatives of our dean. Professor Sutikno, please, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable our Dean, the Honorable Deputy Dean for Academic and Student Affairs, the Honorable Deputy Dean for Planning and Resources, the Honorable Prof. Lee and Delegate, the Honorable Prof. Asep from Universitas Pendidikan Indonesia, and the Honorable delegates from Universitas Pendidikan Ganesha Singaraja, Bali. Distinguished Professor, ladies and gentlemen, it is a great pleasure for me to welcome you to this seminar. I am very happy to thank the professors, lecturers, and student delegation who join us, especially the representative from SOGANG University, led by Prof. Lee. I would also like to warmly welcome keynote speakers. This seminar is a series of collaborative activities within the framework of the LUPIC program, which has the theme Recent Trends in Chemistry Education Research. This theme is very interesting and is an issue that is widely discussed by researchers. For your current information, our faculty has around 20 study centers or research groups. 5 of them are research groups for development of smart science teachers with character, science learning for students with special needs, ethno-STEM-based science learning, evaluation of science learning, and the last is science and mathematics learning innovation. It is generally known that students find chemistry a difficult subject. Chemistry is not just highly abstract in nature, but also get even more challenging because it requires not only scientific skills, but also mathematical skills. This perhaps adds more to students already burdened mind with scientific concept alone. There is certainly a need for more innovative teaching to help students understand, learn, and appreciate the subject. Scientists tend to use mental images and to use multiple representation of phenomena when solving complex problem, and they can switch from one representation to another. Conceptual understanding in chemistry requires the acquisition and integration of multiple representations at 3 different levels. Macroscopic level is the most concrete level of representation. The submicroscopic level is an intermediate level of representation on the concrete to abstract scale. And symbolic level is the most abstract level of representation. Ladies and gentlemen, I hope that the scientific discussion in this seminar forum can produce brilliant ideas in facing the challenges of chemistry education. Let me finally wish you a successful meeting and assure you that I will spare no effort to assist you in forging international cooperation in the field of research, business, and scientific publication. To fulfill the committee request to open this seminar, Bismillahirrahmanirrahim, this seminar is open. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you very much for Professor Sutikno. And now that the seminar is officially opened, I would like to announce that the moments that we have been waiting for is now will begin very soon. So we would like to start the seminar on research trends in chemistry and chemistry educations with Professor Wong Kung Lee and Professor Kwang Hang Jung from SOGANG University of the South Korea. To lead the seminar, let me invite Dr. Sri Kadarwati as the moderator. Time is all given to the moderator. Please, time is yours.
Thank you very much, Ms. Kirindra, for the introduction. The Honorable Professor Won Kuli, the head of Leading University Project for International Cooperation, or LUPIC, from SOGANG University, Korea. The Honorable Professor Kwang Hwan Jung from SOGANG University, Korea, also together with Dr. Sunili. The Honorable the Vice Dean for the Business Research and Cooperation Affairs, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Semarang, Professor Sutikno. All of the lecturers of Chemistry and Chemistry Education Study Program, Universitas Negeri Semarang, and all participants, all of the students, join this seminar in person in this room, also through Zoom. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Annyeonghaseyo yorobun. I'm Sri Kadarwati, would be your moderator in today's seminar. I'm very pleased to see you all here and welcome to all of you in this seminar. This seminar, as stated in the backdrop, is about recent trends in chemistry and chemistry education research. So it will be good chance for you to know more about research in chemistry and chemistry education. We are inviting two speakers from SOGANG University, Korea. Have you been in Korea? No? Same as me. Professor Kwang Han Jung and Professor Won Kuli. I will address both of them as Professor Jung and Professor Lee. Will be presenting about chemistry and chemistry education research trends recently. This seminar would be conducted in panel with 45 minutes talk for each speaker, followed by 30 minutes question and answer session. It will be long seminar, I think. And before starting the session, few information need to be paid attention by all of you. Number one, please silence your mobile phone during the seminar. Yeah, we don't expect there is a sound like Shopee. There is a sound like that. Yeah, we don't expect that. And please keep your question until we reach the question and answer session. So maybe you will need to take a note, yeah, about what question you need to raise later. And then For you who join the seminar through Zoom, please mute your microphone during the seminar, unless you are permitted to unmute your microphone. All right, ladies and gentlemen, without further ado, let's get started with our first session. The first speaker would be Professor Kwang Hwan Jung, Professor Jung from the SOGANG University of Korea. Sorry, it's correct, right? Ladies and gentlemen, please welcome Professor Kwang Hwan Jung. I think I need one more microphone here. Oh, sorry. It's up to you. Your time for presenting your topic is around 45 minutes. You may start if you 45 minutes. Thank you. Oh, you are expected to be seated here. So sorry. Sit here? Oh, no, no. Stand is better. He prefers to stand up. If you
have a pointer, I can. Okay. No, I mean, I just want to.
Please wait, ladies and gentlemen, for a moment.
You want to introduce? You start? Or okay. Okay. Anyway, first of all, I'd like to thank. Oh, this is a different stuff. This is not the. Okay. So this presentation is for one Guli. Yeah. Not this one. Okay. During these changes, first of all, I'd like to thank that Professor Lee and faculty members from UNNES that there's a. I'm happy to be here and great chance to talk about research trend. The scientific research, but many things is about chemistry. And okay, so my name is Kwang Hwan Jung, but pronunciation, even in Korean, it's hard to pronounce Kwang Hwan. So I have another English name, Kevin, and Kevin is easy, right? And also my last name is Jung, but I mean most American, the European call me Jung. So my name changes, Kwang Hwan Jung to Kevin Jung. So anyway, so you can call me Kevin Jung, yeah, no problem. Okay. Okay, I'm professor in life science, but my laboratory is working on protein biochemistry. So I'm working on biochemistry. And also recently, like 3 years ago, I set up the company. And the company is battery recycle, about battery recycle. I'm focusing on lithium. So I'm going to talk about the recent chemistry trend, and also based on this trend, what kind of industrial work is going on. Okay. Okay. So next slide. Okay. So here, actually, I have two websites: www.photoresearch.co.kr. That's my university homepage. So I'm working on protein biochemistry. And the other one is like 3 years ago, I set up a company called Green Mineral. So green is good meaning, right? Recycle. And mineral is really mineral, like lithium carbonate, nickel carbonate. So, and also I'm CEO and CTO. So next slide, please. by myself, I can do it. Okay, anyway, I did or somebody to shoot. Anyway, so yeah, I'm from Korea. So Seoul and then through Shanghai. So I think 4 days ago, I arrived Jakarta and came to Jogja. I have a business in Jogja. And then from Jogja to Semarang, it is the first time I visit Semarang. It's very nice. It's a high place. It's nice. And I came by bus. Okay, bus is also nice. So yeah, yeah. So I came here, and here is my university. Okay, so 2 days ago there's snow. Even end of the February, snow. So yeah, but the temperature is not minus. Actually, it's 1 or 2 degrees, but there's snow, so it's very nice. Yeah, yeah. But the traffic is very, very bad. So anyway, at night it's beautiful. So and also the Sogang University is located at the center of the Seoul, Korea, and there are many universities together. So maybe young people really like this place. A lot of restaurant, a lot of nice place. So if there's chance, you can visit. Okay. Okay. And this is my laboratory is here. So at Sogang University, there are 4 departments: mathematics, chemistry, life science, and physics. Actually, I'm professor in life science. Okay. So actually, I'm working on protein biochemistry. And protein, what kind of protein? And you and human have this protein in the eye. Actually, if you want to see, there's a protein in eye called rhodopsin. So we have 4 kinds of rhodopsin, and there's a color and also brightness we can sense. Actually, I'm working on that protein. That's a membrane protein, and if it absorbs the light and then relay the signal. So that's the reason your brain, so our brain can sense, and then you can see this color and this shape. I'm working on that one. I was working for more than 30 years about this protein. Okay, but like 3 years ago, I was working on protein biochemistry, but 10 years ago, I also working on microalga. So you know alga, right? You like kimbap, right? And the outside the black color, that's alga. Okay? So we can eat, but I genetically modified, and then that alga can change to lithium carbonate. So I can recycle the battery, actually lithium-ion battery. Okay. And Professor Lee and we want me to talk about the recent scientific trend. So I checked, and then there are 8 topics in 2024, and you can see of course, there are a lot of AI, artificial intelligence. So I think you already knew that there's a Chat GPT. Have you used ChatGPT? So you can do the homework by yourself. Okay, so do my homework. You ask the ChatGPT, they do, right? They write the essay and everything. Okay, so, very nice. Okay, but professor doesn't like it, so because we cannot. It's so nice. Is it really you writing or somebody like a ChatGPT write? So anyway, so AI is a hard issue. Okay? But second one is green chemistry. Okay, so there's chemistry, but you have to think about environment, no pollution, and very clean. And also, it is related to the decarbonizing energy. That means we produce a lot of CO2, and then there's global warming. So that's the reason. I mean, I don't know. You always feel hot, or in Korea, it's like summer is really hot, and also winter. Like when I was young, I'm old, so when I was young, I'm something like 10 years old. Actually, the temperature in Seoul in winter is minus 20, around minus 20 degrees. It's really cold for several, 1 month. But really, based on the global warming, right now it's minus 20, no, minus 10 for 4 or 5 days. So that means it's really temperature. what, Earth. The global warming is really going on. So we have to stop that one. So today I'm going to talk about many things about can we stop this global warming? What do you think? So I'm going to talk about that one. So okay, so green chemistry is based on chemistry, and also decarbonizing energy. There are many ways, many ways. So chemistry is involved in this one. Okay? And other stuff is that biomaterial. Actually, biomaterial and a lot of chemistry, a lot of physics, a lot of mathematics involved, and they're good biomaterial. And also another topic is, okay, let's go to the moon. That's another topic. And also CRISPR-Cas is you can knock out the gene in human and also mouse, and you can treat the genetic disease. That's another topic. And ending cancer. That's nice, right? That's nice. Is it possible? Yeah, probably in 10 years you are not going to die with cancer because antibody-based drug is really developing a lot. Okay? Okay? And neurogenetic also, if we can stop cancer. The other problem is like Alzheimer. When you are old, yeah, your mind is something different. It's also disease. So people are focusing on this neurodegenerative disease like Alzheimer or other disease. So people try to develop some drugs for this Alzheimer. Actually, there's some history that like 20 years ago, people start to make the Alzheimer disease, but actually last year, pharmaceutical company, okay, yeah, pharmaceutical company, they give up. Like old idea was wrong, really completely wrong. So this year they start a new drug development. So that's the reason they talk about this one. So I'm going to focusing on these two, green chemistry and decarbonizing energy today. Okay. So green chemistry, what kind of green chemistry people are really are interested in right now? Okay. Some kind of improving green chemistry, that's the basic idea. Reducing plastic. Yeah, we have so many plastics, Okay, stop using, okay? And, or that plastic is something digestible. So plastic, we feel, I mean, original idea of plastic is they cannot decompose. But recent plastic is, you can, I mean, if you let them, they can like trees, they decompose. So that's the idea of reducing plastic. And the other one is battery. I mean, I didn't see many electric car in Indonesia, but in United States and Europe, there are many electric cars. So they don't use the gas or diesel anymore. I mean, all the car company, they start to change to gas-based car to battery-based car. So that means you need very good battery. Okay? So battery is based on the chemistry. Of course, there's a lithium, cobalt, nickel, they involved, but you need to develop a lot of electric car, good battery. Okay? So that's the alternative battery chemistry. And more sustainable catalysis. Sustainable means, I will talk about sustainable, is that we don't produce any more pollution or any more CO2. That's the sustainability. So that's another green chemistry. And this one, recycling lithium-ion battery. Of course, your cellular phone, you have a battery, right? After you use 2 or 3 hours, not 3 hours, 3 years, and then no longer used, but because the capacity is not good. And then you have to recycle. If you throw it away, it become a pollution of the air or pollution of the earth. So we have to recycle. And based on this, I set up the company. Okay? And also, decarbonizing energy is that in the world, they have a big scheme, big idea, big project is carbon zero 2050 in United States and also Europe. 2050, we want carbon zero. That means we produce carbon we reduce the carbon and they are equal. So no more carbon producing. That's a big project. So all this project is really pushing a lot. So in Europe, they made a law. They already made a law, and then they give a tax. For example, like this, you have a water bottle. It's a plastic bottle. Previously, EU or United, they thought how cheap it is. That's the first concern. But right now, they ask like this, okay, your bottle, how to make this bottle? Did you use clean electric energy? They ask like this. Did you use clean, low pollution producing process, any process you have? They ask. If there's something wrong, I mean, like for example, like Korea or other countries cannot export that product to the EU and also in United States. They start make law like this. So recently, everybody knows Samsung or LG. They check all the other company that relate to that company. They ask, okay, when you make some product, you have to use clean energy and don't produce any pollution. If they don't, Samsung cannot export any product to Europe or United States. That's very, very serious, very serious. Okay? So that's the reason today I'm going to talk about clean chemistry and carbon zero 2050. Okay. And also that there's a big scheme. I think you have heard ESG scheme. ESG means environmental, social, governance are the standard. Actually, standard for research and the standard for company, like running company, you have to base on ESG. So ESG means environmental. So that means also talk about Samsung, right? So did you use clean energy, or did you use some process that didn't produce any pollution? That's the environmental concern. Social, okay, social means any work, any slavery work involved or not, or something like this. And governance is that, oh, okay, your company is really clean, okay? No bribe or not at all, something like this, governance. So actually, based on the ESG, all the company, all the research should process based on ESG. That's a big scheme. It's really big project for Europe and also in United States. Okay. Okay. And I'm going to go into the sustainability. Okay. Sustainability. Okay. Here's Earth. And then everybody knows that the Earth's temperature really going up, really slowly going up. Okay. Okay. Do you know that the average temperature of Earth, average temperature? Okay, so north part is very cold. Here is 30 degrees, right? 31, 32 degrees. What's the average temperature of Earth? Okay. Yeah, check Google. Okay. It's 15 degrees. Okay, average temperature 15 degrees. Okay. But it's slowly temperature is really going up. Okay. Okay, and they said, okay, temperature going up. There's a crisis in Earth. Okay, why the crisis on? I said crisis in human in crisis. Okay, and what temperature we cannot survive? It's a okay, environment. Okay, can you survive around 31 degrees, 32 degrees? Yes, right? Yesterday I checked the Semarang temperature. It's 33 degrees. So, but you survive, right? No problem. Okay. So what temperature we cannot survive? It's above our body temperature. Our body temperature is 36.5, 37 degrees. Above that, we cannot cool down our temperature. So more than 37, we die. Okay, average temperature of the Earth is 15 degrees. 37, there's a gap. But global warming is going on. Okay. Okay. And there are fossil fuel, coal, oil, natural gas. We produce a lot. Okay, we produce a lot. And temperature going up. So I think everybody knows that north part, okay, there's ice. Yeah, there's plain, okay, without ice. Okay. Okay. So our temperature really growing up, but suddenly, okay, recently, like 3 or 4 years ago, they stopped producing a lot of gas. Temperature a little bit go down slowly. The reason is Corona. So Corona, you were at home, right? You don't move at all, okay? But you produce a lot of plastic waste, but, but you don't drive a lot. So actually, and a lot of people die because of the Corona. Okay? So our population go up, and suddenly COVID, they drop. And based on this, also global warming is a little bit slowed down. Okay, all the good part, or bad part too. Okay? Yeah, but still global warming is going on. And okay, global warming is based on the fossil fuel burning. Okay? What's the main component it affects the global warming? People think that CO2, of course, CO2 is a major component for global warming, but scientists really worry about methane. Okay, methane, where the methane come from? Cow, right? Floating, cow floating. There's a lot of methane producing, right? That's all based on the methane production. But the global warming effect is more than 15 times, 20 times more than the CO2. So methane is really not good. So we don't stop eating cow or pig or stuff. Maybe we should be all become vegetarian. Maybe not, maybe not. Okay, but okay, so cow. Actually, cow is not a big problem. I mean, scientists really worry about methane because of the Siberia, Russia. Okay? In Siberia, there's a freezing, okay? And a lot of methane is freeze below the Siberia area. Okay? If our global warming temperature really going up, and this ice melt, and then a lot of methane coming out, and then we cannot reverse. The temperature go down, cannot reverse back. That's a big thing. So all the country set up make some negotiation. That first idea was Kyoto Protocol. So don't produce a lot of stuff. Actually, United States doesn't follow that one. But anyway, really worry about this methane. Okay? So a lot of countries are really working about this one. So and also if there's global warming, and then also ocean temperature also increase, right? Ocean temperature. If the ocean temperature 1 degree change means 10-degree change is same thing in the water. So if the 1 degree change in water, that means 10-degree changes. All the the animal and the plant in ocean, they die. 1 degree change, they die. So it's a serious stuff. Okay, so we have to focus on this one, but let me see. Oh. And the question is, can we stop this global warming? Can we stop? What do you think? Can we stop? We cannot stop, we die. Okay, you are not die, but your son or daughter, maybe that area, temperature really going up, and human is extinguished. It's that thing. Okay? So we have to stop. Okay? And first one we have to do is we have to use green energy. Okay? And green energy means environmental friendly and non-polluting energy. Okay? So, okay, we can use gas, but we should not digging the gas anymore. We have to capture CO2 and then use. Okay? That's the whole idea. So that we call it a green energy. So, okay, and then I'm going to talk about a little bit history about green energy. I mean, the big idea is that, okay, yeah. Somebody want to ask question? Yeah, raise your hand and ask it. Okay, so I'm going to talk about a little bit history about the green energy. Okay. Actually, United States and Europe, first, they don't care about global warming. Actually, the George Bush and other presidents, even Trump, they don't believe the global warming, right? Global warming. But when the Bush is become a president, the gas price is really going up. Actually, when I was in the United States, the gas price was $1 per gallon. 1 gallon is 3.8 liters. It's $1. Very cheap, right? But when the Bush become president, the gas price is $4. Okay? So think about your gas price. It was $1, suddenly become $4. 4 times increase, big problem, right? Riding motor, yeah, 4 times increase, problem. So what the Bush thought that, okay, the reason is that we have to control the gas price. And what the Bush did is that they attacked Iraq. Remember, they attacked Iraq. Okay, and they try to control the Iraq the oil stuff, but it failed. The reason is China economy is really boosted up. They use a lot of gas. Still, the gas price is really up. And then Bush thought, okay, actually Bush doesn't believe in global warming, but Bush thought that okay, oil price really going up, I cannot be a president anymore. So he thought that, okay, let's reduce the oil price using bioethanol. So that time it started green energy. Actually, we thought that, okay, green energy is good, and then we can reduce the global warming, we can stop global warming. But originally, the start is from the Bush's idea. But Bush doesn't believe the global warming. He only thought about political stuff. Gas price up, we have to cut down the gas price. Okay, let's use bioethanol. So he first used bioethanol using corn. Okay, corn. Corn is tasty, right? Yellow and tasty. Huh? But it's a food. Okay, not for gas, right? So actually, corn price in Mexico is really become expensive. Because really price goes high. Okay, and Mexico really complain about United States. Corn is food, not for using the car, gas car. And then Mexico complained a lot. Okay? Because in general, people, we have to use corn, but use for bioethanol and use it for car driving, it's not good. So Bush is attacked all over the place, and then Bush changed it. Okay, so they said crime against the humanity, okay? Into biofuel. So Bush, and also a lot of beer, okay? So Bush thought that, okay, let's change the alternative stuff, okay? Not food, not corn, not rice, and then, okay? So they are looking for the other one, okay? And so I'm going to talk about, okay, at that time, what about Indonesia? Also, Indonesia also trying to looking for the alternative gas. So I checked. Okay? Actually, in Indonesia, a lot of coal, but it produces a lot of pollution. So, the Indonesia government looking for other option. I'll go back. Okay. Alternative is oil is biomass. Okay? Oil become so before the Indonesia, people thought that, okay, let's not use corn for food. Actually, they start to use biodiesel using this. After they harvest, okay, there's other leftover. And then they break down and they change this one. This is mostly is a cellulose. They change to ethanol. That's the second generation. And ethanol production, and that's the saving energy. Okay, so Bush thought that okay, corn is no longer used. After we eat, and then we can use this one for making the bioethanol or biodiesel. Okay, that's right. But this one is also a problem. The problem is that the amount of this one is very low, and then the production rate is very slow. You have to use tree, something like this. You have to grow, takes time. So it cannot produce a lot of bioethanol. So third generation is green algae. They grow fast. They can easily change it to not bioethanol, biodiesel. So that's the third generation. Actually, biodiesel is oil. Biodiesel. So they can use this one. And at that time, actually, the Indonesian government thought about palm oil. So you have a lot of palm oil. So palm oil is very good, okay? And vegetable oil, and then food and non-food, okay? Rapid growing, okay? And also, palm oil production is fast and it's tough in Indonesia. Okay? And advantage of palm oil is a highly efficient product and require less than the other oil crops. So palm oil is a good. So actually, Indonesia government, they start to use this palm oil change to, of course, it's a cosmetic stuff, but also it's a biodiesel stuff. But right now, it's stopped. Actually, government control the palm oil right now. Okay? Actually, it's more worse to use the gas than the other stuff. So right now, the government stopped using the biodiesel anymore. Okay. Actually, the Indonesian government thought that if you want to grow palm oil, you have to burn some stuff on the area, and they have to plant palm oil. So it produces more pollution than the stuff. Anyway, okay, so right now the palm oil is right now using for non-food, food or non-food, like a cosmetic stuff. Okay? Right now. Okay, that's the story of the history of how to people start to use biodiesel or biofuel, and then the green energy. Actually, it starts from politics. Okay, and how to reduce this CO2 emission. And right now, people thought maybe we can use wind power, solar power, and fuel efficiency, which we can lower, and then we can reduce the carbon production in the air. And first idea was that Kyoto Protocol, all the country, they negotiate, they control the carbon production. So actually, United States, they are following like the 2000 carbon zero. They are focusing on this project. And also ESG. And we talk about ESG a little bit more. Okay? It's a good idea, right? Environment, social, government, and then no production of CO2. It's a good idea, but original idea, okay? Why United States and Europe thought about ESG? Actually, they try to kill the China. Okay? That's also politics. Yeah? Actually, China, they produce a lot of product very cheap, but they don't care about environment. Right? So if they care about environment, So this price is increased, right? But China, they don't care about environment. So, I mean, if the price competition with the price, I mean, United States and then Europe, they cannot win against China. So they made a law and they made some big scheme, ESG. If you don't use like clean energy, or if you don't care about the environment, we're gonna give a tax, and then we don't import any more Chinese products. That's a politics. Actually, they try to kill the China. That's based on ESG. Okay, but anyway, it's a good. Okay, it's a good for Earth and good for us, right? So anyway, so the first big thing is that how to reduce CO2 in the air. Actually, most of the CO2 comes from the driving the car, and also produce a company production of a lot of CO2. So first, people thought, okay, let's use electric car. The electric car, they don't produce any CO2. But also, this is wrong. But when they make the electricity, how to make the electricity? Is you to burn the coal? Not good, right? That's produce. So when you make the electricity, if you use wind power, sunlight, if they produce clean energy and then use this electricity, maybe it's a clean electric car. But recently, people said, okay, ESG, environment. After you use battery, okay, cellular phone, after you use battery, where this battery go? Throw it away. Okay. There are a lot of metal ion, cobalt, nickel. It produces pollution. So actually, I set up the company. Okay, I call Green Mineral. That okay. So after you use all the battery, you have to recycle, because if you put there, or if you burn, there's air pollution, and if you keep there's a metal, there's a lot of pollution. So you have to recycle. How to recycle? I mean, traditional method is that you use sulfuric acid to dissolve, and then many organic solvents you add, and you can precipitate. Did you take some analytic chemistry course? Oh, okay, instrumental analysis course. If you want to check the metal, nickel, cobalt, or copper, or ferrous, you add the sulfate, and then you use organic solvent to precipitate. That's the easy way, right? But if you use organic solvent, it produces a little bit more pollution. Okay? It's not green chemistry, actually. Okay? You have to use less organic solvent or less amount of other chemicals. That's the green energy, green chemistry. So actually, I was working on the green alga. Actually, green alga is I call chlorella. Have you heard of chlorella? Actually, you can eat, edible. And actually, and also, have you heard biomineralization? Biomineralization is your bone. Okay? It's a calcium sulfate. So your cell produces your bone. It's a mineral. Okay? Your bone, or when you eat clam shell, that's calcium carbonate. That's biomineralization. Actually, the cell produce mineral and attach to CO2 and then make some mineral. That's biomineralization. Okay? Actually, I use the same thing. The chlorella, actually, if you put the lithium ion in, okay, so chlorella into lithium ion, they produce lithium, attach the CO2, and then they produce lithium carbonate. It's the same biomineralization and precipitate. So and then I genetically modified, and then if you put the battery solution after you add the sulfuric acid, there's a nickel, cobalt, lithium. If the chlorella in there, they change nickel to nickel carbonate, cobalt to cobalt carbonate, lithium ion to lithium carbonate. Okay? So I set up the company, and actually, and the EU, they made a law. Okay, recently EU and United States, they really passed a lot of law based on the ESG. Okay? What kind of law? 2030, you have to use 4% of the recycled lithium you have to use, and 10% of nickel you have to use. Recycled nickel you have to use. Okay. 4%, 10%, you think very small, but that 10%, 4% is at 2030, they need this amount of the lithium you need, but only 4%. But calculate to the 2024-25, we have to recycle almost 60% of the battery you have to recycle. That amount is the same amount of 4%. That means right now, a lot of battery coming out, more than 60% you have to recycle. And then recycle the lithium, cobalt, nickel, you have to use back to the new battery. That's a law. Just last year, they passed the law, EU. And also, they have another one based on the ESG. If you don't use clean energy to produce lithium carbonate, they give a tax. So how much tax? 200% tax. Okay? Think about it. Tax is not 30%, 40%, 200%. That means if the price is $1, it becomes $3. So they block all the Chinese lithium carbonate or lithium hydroxide. That kind of stuff they right now. Okay? That's a trend. So trend is that, okay, green chemistry, also 2050 carbon zero, that's a big scheme. All the country, they push to that one. Okay? And the idea is that, okay, after you use a battery, and then you put the chlorella in there, and 8 hours, this chlorella can precipitate 70% of the lithium you can remove. Okay? Okay. And you can see under the microscope. So here's a movie. Okay? So chlorella is very small. The diameter is 10 micrometer, very small. Okay? If you incubate with the lithium, they produce a lot of lithium carbonate. And we can isolate later. Okay, so right now, okay, so this kind of development is the future. That a lot of, okay, based on a lot of, you learn a lot of instrumental or physical chemistry or organic chemistry or inorganic chemistry, okay? Based on that one, also a little bit biochemistry, you combine, and then in the future, you have to what the direction is green energy, green chemistry. You can produce some product based on green chemistry. Your what's that product will be successful. Okay, so I just want to introduce my company. That last year I got the investment of $5 million, and then we set up the pilot scale reactor. That means 500-liter scale set up, and then we start to produce lithium carbonate, very clean, environmental friendly lithium carbonate. And it's in Korea, and then we set up so many reactors, and then, okay, of course, green alga. If you want to grow green alga, okay, alga is easy to grow. You know it. There's water in the ocean or whatever. There's CO2 and sunlight. They grow, right? They grow. It's easy to grow. Okay, and my company, there's workers. Okay, okay. So let's summing up that, summarize that. Okay, you want me to talk about the future? Okay, future recent trend. Actually, recent trend is that green chemistry and carbon zero 2050. So all the research and all the company, a lot of law, they push that toward to that one. Okay? So, 2050 CO2 lower, and so all the country previously they use a lot of gas and oil, coal, but they change to biomass, and also sometimes they use nuclear power, but nuclear power is also dangerous. Okay? So there's many biomass, and they try to lower down the CO2. Okay, so that's finished. That's all the talk. I finished. So if you have any question, yeah. Thank you.
Thank you very much, Professor Kevin Young. You may be seated first. Yeah, we want to invite the second speaker, but before we start with the second speaker, I would like to greet Dr. Zainal Abidin. I forget to mention you, the Vice Dean for Academic and Student Affairs, Dr. Zainal Abidin. Good morning. And ladies and gentlemen, Yorobun, I would like to highlight some important points from Professor Young's presentation. So now you have, or you got an idea for your thesis, maybe, or your student creativity proposal, maybe, about green chemistry and carbon zero energy. When I want to make some comments first, yeah. I think you don't mind for that. If Professor Young said that, oh, if you you have old mobile phones, and you throw it away, it doesn't happen in Indonesia, Professor. If we have old mobile phones, we sell it. We sell it. we don't throw it away. Just small comments. Sorry for that one. All right, ladies and gentlemen, as I said before, that this seminar will be conducted in panel. So we would like to invite the second speaker, Professor Won Lee. He will be presenting about research trends in chemistry education. Please welcome Professor Won Lee. Actually, it's okay, you stay. Oh, okay.
Good morning. Selamat pagi. 안녕하세요. My name is Won Lee, and I visited Indonesia about 50 times. 50 kali. Yeah. For the last 6 years, because I had a collaboration with Sanata Dharma University in Yogyakarta. So that's why I visited Indonesia so many times. During those times, this is my third visit to Semarang. And I'd like to thank you all to welcome us. And I'd like to introduce some changes in educational field, especially chemistry education in Korea. I plan to invite Professor Jung Dae-hong from Seoul National University, but unfortunately he had business in America, so he is staying in America. And he sent me his presentation file. So I present his file on behalf of Professor Chung. And before I start my presentation, I like to introduce Korea a little bit. South Korea is a very small country. The land is smaller than Java Island. So very small. and we have about 50 million people. And Korean Peninsula, almost 70% is a mountain. So we cannot live in the mountain. So we can only live in 30% of the, of the area. That's why everywhere is so crowded, so many people. And like I told you, we have 50 million people in South Korea, and 25 million, 50% of the whole population living in Seoul and suburban area. So Seoul is a huge city, mega city, with so many people, so many cars, so we have so many problems. And 10 minutes ago, your vice director asked me why Korean people working so hard, day and night. We always walk and walk. The reason is that in Indonesia, how many times you can grow rice a year? How many times? Minimum 2 times, 3 times, maybe 4 times. Yeah. So food is available. Food is available all the time in Indonesia. You can find the fruits all the time, all year round. But in Korea, we can grow rice only 1 time, during summer time, during summer, from June to September, right? So only 1 time. And we have a long winter from November, December, January, February. It's a winter. Now it's a winter in Korea, very cold. We had lots of snow last night. Yeah, you saw those from the slide from Professor Kevin Jung. We have snow like in some mountainous area. We had snow 1 meter in 1 night. Right? So that means we cannot grow any food. So that's why. That's one of the main reasons we have to work very hard to save food during the winter, right? Otherwise, we could not survive. But these days, we can find fruit all year round. Even in winter, we can buy strawberries, we can buy grapes, we can buy watermelon now in Korea because we have so many greenhouses. So we can grow fruits, but the price is unimaginably expensive. But we can find food. So that's the difference between Korea and Indonesia. So I always tell Indonesian people, you don't have to work that hard, right? Everything's available all the time, right? Why work hard? When you have everything. So let me start the main slide. Can I move to the next slide? Okay. Starting from the question. Now we have 2 containers on the scale. This is in vacuum. There's nothing in the container. And we have an air molecule in the left container. Now, which one is heavier? This 5,000 rupiah price. So, out of 2 containers, which one is heavier? Anybody has an answer? Yeah. This one. This one would be heavier because there are air molecules inside the container, right? Anybody? How about you? What do you think about this problem? Any answer? No? So let me figure out what would be the answer. Okay. Next slide, please. have the next slide. Okay. Yeah. Now, this air molecule is constantly moving, right? And some air molecule is moving upward, and some air molecule is moving downward. Downward moving will increase the weight, and upward moving will decrease the weight. So by statistics, the upward moving molecules, the number would be same as the number of the downward moving air molecules, right? So would there be the weight changes? You know? How do you think about this? Hmm. Hmm. Yeah, still the same number of molecule is moving upward. Yeah. This would decrease the weight of the container, and the number of molecules moving downward will increase the weight of this container. And by statistics, that would be same, right? So no increase, no decrease. So the answer would be the weight of these two containers would be same, right? Yeah. So the left balance. Sum of the force by bottle itself, bottle plus force E, right? And force C, this would be cancelled. So the weight of these two containers would be the same, right? Yeah, that would be the answer. Can we move to the next slide? Yeah. So the next, please. Move to the next. Now, so how can you explain the different interpretation, right? Somebody would say the left container would be heavier, and somebody might say that would be the same, and somebody may say the left container would be lighter than the right container, right? So when you say the answer, you need to explain why, right? So we have to think about this problem. Can we move to the next? Now, what happens if we increase the size of the container? Okay. So this is 10 centimeter high. This is a 100-meter high container. Is there going to be some change between the force, upward force, and the downward force? So force B and force C would be same, right? In this case too, force B and force C would be same too, right? So the container, the weight of container, this container and empty container would have same weight, right? Based on the result, the previous case. Right? Even though you increase the size of the container, there is going to be no change in the way, right? Now, we have the question, knowledge versus thinking. Knowledge is something we learn from the media, from the book, from your professors. That's a knowledge. But thinking is a little bit different. Can you teach thinking to the students? Maybe we can teach how to think. Yeah, that's not easy to teach how to think to the students. And we move to the next, please. Next. Now, amount of knowledge increase every day. Every day we have new things coming out. New findings are coming out every day, right? So we cannot teach all the knowledge to the students. But thinking ability is different, a little bit different. Thinking ability, we can teach students thinking ability, how to think about the problem. If we can teach how to think to the students, they can be problem solver, right? So when you have a problem, the first thing you need to do is you analyze the problem. What is the problem, right? And you need to think about how can you solve the problem. If you know how to think, you can do it, right? Even though you did not have knowledge. That's the difference between knowledge versus thinking ability. Can we move to the next, please? Next. Next, please. Now, these days, technology development in big data and AI changes very fast. Professor Jung talked about ChatGPT, AI thing, right? So, as the technology changes, the environment also changes too. These jobs are highly replaceable by AI. The number one. Somebody working at the construction field, Then in the construction field, these days, we don't need many people. Machines do many things, right? Now, second one is a butcher. Kill cows, kill kambing, and kill fish, right? In a big factory, they do those jobs by machines, automatic. Now we are using so many the cameras. Cameras are everywhere. In Korea, cameras everywhere. CCTVs everywhere. So they know what you are doing. So we do not have many criminals these days because if somebody commit a crime, those cameras can follow him. So we can easily catch those criminals. But the job on the right, it's not easy to replace by AI. Artists, painters, and sculptors. Artists. These days, AI can draw some paintings and do some job, but still, it's not replaceable easily. And photographer and writer, these kind of jobs are not easily replaceable by AI. So you need to think about very seriously what kind of job you want to have when you graduate. If you want to have a job on the left side, that would be very dangerous. That can be replaced by AI and machines, right? So you need to think about that. Can we move to the next slide? Now, in the past, we taught students how to solve the problem. That was industry-based society. Now the society is moving to knowledge information society. So we need to change how to teach students as the society changes. And the change is very fast, right? Next slide, please. We will face many challenges. The recent challenge was COVID, right? So everybody in the world suffered a lot because of this COVID viruses. Now, is it the last challenge to the human being? The answer would be no. So we need to expect the next challenges to the human. So we need to prepare for the next challenges. So during the COVID period, the educational environment changed a lot. So most teachers made the online lecture material because students could not come to school. So we needed to provide online educational material to the students. So we developed the online lecture system. All the universities and high schools and middle schools, elementary school even, they developed the online educational system during the COVID. And we also developed data sharing tools, like a Zoom, right? Nobody was interested in the Zoom before Corona. But as the Corona begins, everybody wanted to use Zoom. So the market value skyrocketed as the Corona begins. And Wi-Fi network is allowed to students, everybody, not, I would say not everybody in the world, but most of the students can access to the Wi-Fi so that they could access to the online educational system. And portable devices were distributed to students. So these are the changes we experienced during the COVID period for the last couple of years. And this kind of changes would be accelerated in the future. Can we move to the next slide, please? Now, in Korea, we had a curriculum reform in 2022. So, the attitude of self-directness and community changed to life-related competency education. The individual learning experience through the student-tailored curriculum and freedom of curriculum was expanded. And from the offline education to digital and remote education. So prepare learning environment for digital and AI education. So that was the change in Korea recently. Can we move to the next slide? Okay, so we need digital literacy and computational thinking. So if we combine these two, we can accelerate the education, the higher education. Next slide, please. Now, what kind of changes are happening in some countries? In Korea, from STEAM education to integrated thinking. We encourage integrated thinking. From software education to future computational thinking. And the running model, we established some running models, school, for future education. How about in Singapore? Singapore enhancing teacher competency and collaboration, collaborative learning and learner-centered education and authentic learning. I don't know what authentic learning means, but learner-centered education, that's kind of a tailored education. Because all the students are different. So we need to customize the educational model for each student, that means. In the United States also, they are transforming their educational system for the future. Yeah, these are changes which are happening right now in the globe. Can we move to the next? Now, what kind of competencies we need for the future society? This red-colored word, collaboration, communication, digital literacy, and technology, and one more thing, critical thinking. So I always say 4 C's. We need 4 C's. Critical thinking and communication, collaboration, and creativity. That's 4. We need those 4 C's in the future. Can we move to the next? So in the future education, we need a learner-centered active engagement, right? Not the educator-centered, but the learner-centered education we need. And learning experience in authentic context and problem solving with the discussion and collaboration. Now, I keep saying collaboration. Collaboration is important because as the society changes and the technology develops, it's getting more complicated. So each person cannot solve anything. One person cannot solve any problem. So we need collaboration and communication skills with other students. So if you can develop communicative skills and collaboration skills with other people, you will be very successful in the future society. They are very important in the future. Can we move to the next? Okay, next, please. Now, this is what's happening in Korea. So we have this kind of classroom, right? Online, this is for online class. And this the classroom, right? We have a smart board here, and we can have small discussion groups. And each students have PCs, right? So can we move to the next? Now, these are model for future school. Right? So many schools, there are many old schools, old buildings, which was built more than 40 years ago. So they are remodeling those school buildings to like this. Right? So the classroom is not like the classroom I learned maybe 50 years ago. So if I go to elementary school these days, the classroom is a lot different from the one I experienced long ago. So the schools are changing like this. And can I move to the next? And like this, some schools have a rooftop garden, and some schools have this kind of a space for open communication between students. And some schools have VR and AR rooms. So they are trying to have smart classrooms these days. As you may heard the news from Korea, the birth rate in Korea has been decreased a lot. So that's a big social problem in Korea now. The average birth rate in Korea now is 0.7, not even 1.0, 0.7. That means the population will increase very fast. So when I was in elementary school, the number of students in one class was like 70 kids in one classroom. And some schools had morning class and afternoon classes, because there were so many kids in my age. But these days, if I go to classroom, the number of students in each class is about 20 to 25, right? So there has been a big change, and that number will decrease in the future based on the birth rate in Korea. So we need to prepare for that changes. Can we move to the next, please? Now, this is a different observation. So what can we find from the data? This is a classroom, maybe a middle or high school classroom, and this is CO2 concentration, right? Based on the time. We can put a CO2 sensor in the classroom. Right? It's a small device, very small, simple device. And CO2 concentration is increasing as time goes by, and this is a break time. Yeah? During the break time, we open the classroom door, then we refresh the air a little bit, then CO2 concentration drops. Then after the break time, the CO2 concentration is increasing again. But you can see there's a slope change, right? The slope is like this, and the slope is this, right? The slope is a little bit sharp after the break time. And many of you may have experienced in the classroom, you felt very sleepy, right? During the classroom, right? Everybody knows, right? I also experienced. Now, what would be the reason why you were sleepy? Because you had a big food during the lunchtime? This might be the reason. As the CO2 concentration increases, then you feel sleepy, right? Can we move to the next? The next? Oh, the next, please. So, when the CO2 concentration reaches 4,000 ppm, you start to feel sleepy, right? So, this is the reason why we refresh the air in the classroom constantly, right? To not make students sleepy. This is why we open the door here, right? To make you not sleepy, right? Can we move to the next? Yeah. Next, please. This is another experiment. We can put the sensor, moisture sensor, and temperature sensor. So moisture and temperature moving oppositely, right? When moisture temperature moisture high, temperature low, like this, right? So we can find the relationship between the moisture and the temperature by using simple sensors. Next slide. And in some schools, they use IoT, Internet of Things. So they grow some plants here, and they put some sensors in the container. So they monitoring photosynthesis and respiration of the plant by using sensors. Move to the next, please. The next, please. And these are some research areas from Professor Jung Dae-hong at the Seoul National University, and he's developing nanosensors. So, using nanosensors, we can do many things. And next slide, please. Next. Okay, to the next. Here is Professor Jung Dae-hong. Someday I would invite him to Semarang, so you will listen to his talk directly. And next slide. And one of his research area is developing nanosensor to diagnose pancreatic cancer. The pancreatic cancer is one of the worst cancer we can have because it's not easy to detect in early stage. So when we figure out we have a pancreatic cancer, usually it's too late. So he's trying to develop develop sensors which can detect the biomarkers in early stage of this cancer. Can we move to the next? Now, this is another application of nanosensors. If we put nanosensor on the plant, okay? And when insects invade the plant and start to eat the plant leaves, the plant produces the defense chemicals, right? So that sensor detects the defense chemical, those defense chemicals, which is produced by plant. Human being cannot see it, but sensor can detect it. And the sensor communicate with the computers, our computer using internet. So we instantly knows, oh, there's something happened to the plant. So we can spray the pesticide, or we can take care of those problems. So these kind of nanosensors can be used in many different areas. Can we move to the next slide, please? Please, next. What is this? This is early diagnosis of Alzheimer's disease. This is another serious problem in the globe, not even Korea. It can happen to Indonesia and in many countries. As the average life expectancy is increasing, right? What is life? 70 is too low. Yeah, in Korea, the average life expectancy is between 80 and 85. Yeah, one of the longest in the world. Yeah, with Japan. So we live too long, actually. So as we grow old, many people develop Alzheimer's disease. That something is wrong in the brain, right? But the problem is it's not easy to detect Alzheimer's disease in early stage. Now we have drug, we have a medication, which was developed in America by Eli Lilly Company, a huge pharmaceutical company in America. They developed the medication for Alzheimer's disease. But the problem is diagnostics is not easy, right? That's the problem. So to take care of that problem, Professor Chong is trying to develop a kind of sensor so that he can diagnose this Alzheimer's disease in early stage. If we detect early stage, then we can treat the disease much easily. Can we move to the slide? Now, I talked about some problems we have, and what would be the common to these problems? Can we move to the next, please? The common thing are no answers are found yet. We don't have answers. This is authentic problems, and this is a real life problems. So we need to think about how can we solve this problem. Next, please. Now, again, to solve these problems, we need 4 C's. Critical thinking, right? Critical thinking. And we need a creativity to solve the problem. Each person cannot solve this problem, so we need to collaborate with other people, and we need to communicate with other people to solve these complex problems. So these are things you need in the future. My time is gone already. I'm old enough, more than 60, right? So my life has like 15 years. At most of 20 years, I'll be gone. But you can live more than 50 years. So these are your problems, not mine. So you need to, somebody in your age have to solve these problems. Next slide, please. Next. Now, here's another question. This is a flame experiment, easy flame experiment. If you put the needle, wire, in a solution, then put it in the flame, and you see the yellow color. What that means? What's in the solution? Sodium, right? Sodium. Good answer. And if you have orange color, what that means? Calcium. So these are different. So somebody can say, oh, there's some contaminant in the solution, right? With sodium, there might be some other metals in the solution. Okay? So let's find whether it's true or not. Now, these are sodium flames, right? Yellow. So if we use the spectrophotometer, right? The yellow, sodium flame, and this is orange color, right? But the position is the same, right? So if two lines have the same position, what it means? The frequency is the same, right? Why we have different colors then? That's the question. Next slide. Move to the next. Okay. So the professor asks you, what can you see? The student 1, the color is different. For student 2, line position is all the same. Right? Next, please. So what this means? I don't know, right? Is the hypothesis right? Or no? Okay. Next, please. Next. So the problem is like this. The light from the same light source, okay, here, passes a beam splitter, the filter. The number 1 is filter. Is ND filter, neutral density filter. Then go to the line beam splitter, and one goes to the image camera, goes here, and one goes to the spectrophotometer. Right? Then the problem is here. So this filter reduces the amount of light. Right? When the source goes through the filter, the light, they reduce, the filter reduces the amount of the light. So that may cause a problem. Can we move to the next slide? This is another interesting observation. Now, we know the property of material does not change with phase change. This is the dry ice, solid carbon dioxide. The dry ice changes the phase from solid to gas directly. They do not go liquid phase, right? That's what we know. So when we put the dry ice in the balloon, then check the weight, 3.6 grams. And as the solid dry ice changes to gas phase, the balloon, volume increases, right? So volume is increasing, right? But the weight is decreasing. What's happening here? As the volume increases, the weight is decreasing, right? What is happening? Can we move to the next, please? Now, what causes the reduction of the weight? Why the weight is decreasing? And to solve this problem, what can we do? Can we move to the next slide? Can we move to the next? Now, let's measure the volume, right? Volume of this balloon. So the volume of the balloon can be calculated by this equation, right? So if we measure the radius, then we can calculate the volume. So at the beginning, move to the next. Now, the buoyant force, the force try to go upward, right? This can be calculated by density times volume. Right? Weight change can be calculated by density times volume change of the object. Now, if we plot the weight change versus a volume change, we get straight line. But in realistics, when you do this calculation, the curve is not a straight line. It's like this, right? Deviate from the straight line. Why this kind of things happening? The reason is a leaking problem. Some of the carbon dioxide is escaped through the balloon, right? If we see the volume, we don't see any hole on the balloon, right? But if we look at the balloon, magnify the balloon, there are small holes. So gas molecule, CO2 gas molecule can escape through the holes. That's why we lose the weight. So that was the reason. Can we move to that, please? Okay, so this is the weight difference, and this is the volume difference. We can calculate the weight difference and the volume difference, right? So we should have a linearity like this. Can we move to the next? But this is, right? But if we do this, the volume change and weight change plot, this is almost straight line, right? So can we move to the next? This is another example of Charles' law. This is volume versus temperature problem. If we increase the temperature, volume increases, right? So we expect a straight line. Can we move to the next, please? Move to the next. 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 So if we put the temperature the thermometer outside of the gas or inside of the gas, we would have the same result. Can we move to the next, please? Next. Yeah, we have a straight line here. So this is the last question, last slide. Now we have a scale here, and we hit this porcelain more than 200 degrees. Hit the porcelain very high, 200 degrees. Then put the porcelain on the weight, the scale. Now, as the time goes, the weight of this is increasing now until here. Then it saturates, it flattens. So why the weight is increasing in the early stage? This is the question, last question, right? So this is take-home question, and you need to think about why the weight changes. Weight of this does not change. When we put this on the scale, the weight does not change, right? But that material, hot material, is the weight. What would be the reason? That's the last question, and this is the last one. Thank you very much for your attention. And I introduced some changes in educational environment in Korea and in other countries. So that will happen to Indonesia too. So you are mostly young generations, and you will live in the future, and you need to prepare the changes in the future. Okay, thank you very much. And this is
Thank you very much. Thank you very much, Professor Lee. I would like to also invite Professor Kevin Young to be on stage to have a discussion with all the participants. So, Yorobun, you learned something today, yeah? From Professor Kevin Young, we learned about politics, yeah? And then history, also science. From Professor Lee, we learn also about how different the activity in the laboratory between us here in Indonesia, especially at Universitas Negeri Semarang, compared with the activity in Korea. So, do you want to go to Korea someday? Oh. Now we have come to the question and answer session, and I invite to all the participants, whether joining this seminar in person here in this room, also through Zoom, to ask questions or give opinions. And anyone from you want to ask question, please raise your hand first, and then wait until the microphone reach you, and after that mention your name, mention also your study program and to whom your question is addressed. We will have 2 persons to ask question. Yes. Don't forget to mention to Professor Young or to Professor Lee, your question will be addressed.
Thank you, Bu Srika. My name is Trisulistyo Sudrajat Mardika, and I'm come from chemistry study program. I have question for both professor, but I first want to ask to Professor Kevin Young. So you talk about the changes of from the energy, old energy to the alternative energy. We have lithium ion energy, we have bioethanol, but the problem I think is the alternative energy have some equal ability as the old old energy, such as when we talk about the now generation alga, is they have the same ability as the lithium or inorganic material compared to the biomaterial. And to the Professor Lee, I think I have 2 questions. So to have critical thinking, I think, is the objecting to see the problem has a limitation because each person has different point of view to see the problem, and to have some ability for critical thinking, do we need to have step so we can reach our goal when we solve the problem? Thank you.
Thank you, Trisulis. Also, I would like to inform for you joining this seminar through Zoom, if you want to ask any question to our professors here, please also click the raise hand button in your Zoom window, and then if we already permit you to unmute, you can unmute your microphone and proceed with your question. Don't forget to mention your name and your study program. One more question, please. Oh, okay. Over there.
Okay. Okay, thank you. Annyeonghaseyo. Let me introduce myself. My name is Karima Dulusna, and I'm from chemistry education. And This question may be from for Professor Kwang Huan John. Yes. Sorry for the spelling. Okay. The question we all know that Indonesia have the center of TPS, tempat pembuangan sampah in Bantar Gebang, Cirebon. Yes. And then rubbish there is so full. And then we call it mountain rubbish or rubbish mountain in Bantar Gebang, Cirebon. Sorry, pakai bahasa Indonesia atau tidak ya?
You may try to use English first, and then I would like to later on I will help you to paraphrase with Professor Kevin.
Okay. And we know the environment is have to processing the rubbish in Bantar Gebang, but we don't know the effect about environment processing. We still can see in Bantar Gebang the rubbish is so full. Nah, this problem yes, the problem is there any connected with green chemistry. Yes.
That's all, or more questions?
More.
Oh, more questions.
Yes.
Okay, go on.
In Indonesia, yes.
Oh, okay. You can say it in Bahasa Indonesia or
Okay.
Indonesian language. It's okay. I
Thank
will
you.
write down for you.
Thank you. Permasalahan ini kan ada kaitannya dengan green chemistry. Nah, bagaimana sih cara atau konsep green chemistry untuk menanggulangi permasalahan tersebut? Karena kan kita tahu bahwa di pemerintahan Indonesia ini mungkin sudah melakukan penanggulangan atas sampah yang menggunung tersebut, tetapi kita belum melihat secara jelas bagaimana mereka itu menanggulangi. Karena kan kita masih melihat gunungan sampah itu masih terlihat jelas seperti itu, Bu. Bagaimana konsep dari green chemistry itu untuk menanggulangi permasalahan tersebut seperti itu?
That's
Okay.
all.
Yes.
Thank you very much.
Thank you.
Husna.
Kamsahamnida.
So you could speak Korean more fluently, yeah? Thank you. There are two persons asking questions. The first is Trisulis from chemistry study program. The first question is about energy, alga versus biomass. Yeah, what is the opinion of Professor Yang regarding these problems? Also to Professor Lee about critical thinking, how we reach the critical thinking level. Yeah, probably we give the chance to Professor Lee first. I'm so sorry. To answer the question about critical thinking. After that, followed by Professor Yang about energy and also mountain of rubbish, yeah, from Husna. Please, Professor.
That's a very nice question, and welcome the chemistry study program. I am from chemistry department, so the critical thinking problem is not an easy one, right? So that can be done by training. We cannot reach here from zero directly. No way. That's not happening. So you need to train yourself. Then as you train yourself and practice, then you will find your level of critical thinking is changing, right? So that's my question, my answer. And I know that's not easy. Yeah. But if you keep trying, yeah, you will find yourself is improving. Right? Yeah.
Thank you, Professor Lee. So keep trying, keep training yourself. Yeah. Uh, the next question is about energy, and also I would like to rephrase the question from one female student over there. So we have a certain location in Indonesia where public can throw the rubbish or garbage away in that location, and it becomes a mountain because we do nothing. Sometimes only poor people go there and then just pick something from there. But government or the impact of the mountain of rubbish is very dangerous for our environment. So in the point of view of green chemistry, how to overcome that problem?
So,
Thank you.
uh-huh. Oh, okay, yeah, okay. So I speak loud, okay? Okay, energy efficiency, you ask, okay? Okay, so actually there's a, if you want to move some machine, there's a energy, potential energy change to mechanical energy, right? Okay, so there's some efficiency we are talking about is that, okay, there's a potential energy to mechanical energy. If you use like a coal or like a carbon, like a gas, the efficiency is 12%, 12%. Rest of them, 80% is produced by heat. Okay, actually heat is not good energy. Okay, okay, it's warm. That's all. You cannot move any stuff. But the biological transformation is about 30%. Okay, energy efficiency like photosynthesis is about 30%. Okay, so based on energy efficiency, okay, biosystem is good, but takes time. Okay, so if you want to use gas or oil, immediately you take it out and then use. Okay, of course 88% is caused by heat, and also cheap, because a lot of history that you can use for gas and a lot of system is based on the gas. Okay? And biosystem efficiency good, but slow, and also it's not developed yet. So actually carbon 2050, they try to move from this gas base to the the carbon zero base. It takes time because we very adapted to the gas system. But based on the global warming, we should move from this to this. And also efficiency is better, but takes time, slowly. So that's kind of two things. Okay, okay, it's good for Earth. Also efficiency good, but slow. We already adapted to the gas system. Can we throw it away easily? Probably it's not. So it's just slowly moving. So that's the reason 2050 is 25 years from now. But slowly we have to go there. Okay, that's the first answer. Okay, okay. Second one, there's a lot of garbage. Okay, so same thing happened in Korea like 30 years ago. Okay, and government at the time, that was very brilliant idea. That okay. So there are two ways to solve this problem. One is there's some low low level, like a city, there's a below some level, they they move all the garbage to there and then push into the ground, make them flat. Okay, that was previously Korea did, but you don't have to do that. I mean, actually in Korea right now is we don't have pile of the garbage, but actually we separate like a biodegradable or like a plastic. You can produce biodiesel. If you cannot, you can burn and then you can produce energy. So in Korea, we built one of the the waste treatment plant nearby, and then we separate three things: biodegradable, you can use fertilizer or some food, The other one is plastic. You can produce biodiesel or bioethanol. And the other one, rest of them you burn. And then if you burn, you can get the electricity. So there are three ways you can treat with some plant, and then you can remove step by step. You can remove. So I think your government maybe think about that kind of solving that problem. Probably need some budget. So maybe I think that your government will treat this kind of thing soon. I think, I hope. Okay.
Do you need me to translate the answer? Yes. Oke. Di Korea juga seperti itu dulunya, ya. Tetapi kemudian pemerintah Korea itu memberi solusi begitu ya, membangun plant untuk pengolahan sampah. Nah, sebelum diolah itu harus dipilah dulu. Sebetulnya we already do that in Indonesia. We separate the kinds or the types of garbage. Pemilahan dulu dari yang bisa didegradasi, bisa terurai dengan mudah, yaitu digunakan untuk kompos. Perlu satu plant sendiri ya. Kemudian ada yang dipisahkan, misalnya plastik yang bisa di-recycle ya. Kemudian bisa juga yang ketiga adalah kalau nggak bisa diapain ya. Jangan biarkan saja, karena itu akan menumpuk kan. Nah, itu akan dibakar, producing heat kan. Nah, heat atau kalor itu nanti bisa diubah menjadi electricity atau listrik begitu. Ya, oke Husna. Kamsahamnida. Thank you Professor Kevin and Professor Lee. I would like to also invite the participants from Zoom. There is one people want to ask question. Josephine Debbie. Hi, Debbie.
Thank you, Rika.
Okay,
Thank you,
go
Ms.
on.
Rika. Annyeonghaseyo, Professor Kwang Hanjang and Professor Wang Kali, Nanan Debbie. I'm very sorry that I can only say that, even though I quite often follow Korean drama. I'm very sorry that I have to turn off the camera because of signal problem where I am very bad. I hope the signal doesn't cut out in the middle. Professor Wang Hangjang, I read a lot about SOGANG University, and I found that SOGANG University is one of the top private research university in Seoul, South Korea. One topic that become a research trend is green chemistry. What I want to ask is, as scientists, what things should we pay attention before carrying out development and research? Which do we need to prioritize? Between maybe short-term, long-term, energy, humans, nature, or emission effect? And then I want to, I have permission to ask a question for Prof. Won Kolichu. I was very impressed with the explanation, with your explanation. I increasingly want to go to Korea. One of my dreams is to eat Korean strawberry directly in Korea. Really hope that can happen, and I also want to meet Yoon Pim. The use of AI is very widespread, Professor Koli, of in the world of education, especially in Indonesia. All tasks can be complete with ChatGPT, Perplexity, and the other AI. So what step can teachers take to minimize this? It is possible to maximize total learning in the classroom as a solution, because teacher can supervise student directly. And how can we build the student self-confidence so they can use AI more wisely? Okay, thank you.
Thank you very much, Debbie, for your two questions. And one more question, please. Oh, okay. Della Gita. Her name is Della Gita.
Okay.
My name is Della Gita Puspitasari. I am from chemistry. Okay. My name is Della Gita Puspitasari. I am from chemistry. I have a question for Mr. Lee. What is the correct way to implement a green chemistry system if the research application still uses chemicals that may be dangerous and will certainly create new ways that will actually have a bad impact on the environment? Thank you.
Thank you very much, Della Gita. I want to confirm to Della Gita, are you addressing your question to Professor Lee or Professor Kevin?
For Professor
Professor Lee is over here.
Sorry.
Professor Kevin, yeah.
Yeah.
Okay.
Sorry, Mister.
Thank you very much. We have three questions actually. One for Professor Lee and two for Professor Kevin. How to minimize, Professor, the use of GPT or AI during the learning, for example, because sometimes we use it not in a good way, probably. Thank you.
I think there is no way to reduce the using of ChatGPT or AI in the future. We will use more and more AIs and ChatGPTs in education. How can we, the thing is, how can we use that new technology in good ways, right? That is the question. We use automobiles and motorcycles every day, but while we are using automobiles and motorcycles, we always have statistics. We might have accident, right? Even though we expect accident, we are not using automobiles or motorcycles in daily life. That kind of things, I think. So as the technology develops, more and more AI things will come into our daily life. And we have to decide how do we use that new technology, right? And just prohibiting the technology is not the answer, right? So we need to find a way we use that new technology in wider way, right? Yeah, that's what I think.
Thank you very much, Professor Lee. So control yourself, Debbie. Yeah, decide yourself whether you need to use that technology or not. That's up to you. And then another two questions for Professor Kevin. Yeah, the last question from Della Gita, the female student over there, is how do we use green chemistry in research? And also one question from Debbie, how the factors of research in chemistry, like human and then other things, could impact the laboratory activities.
First question is, can you explain the first question?
I would like to confirm with Debbie as well, Professor, when I reparaphrase the first question. Hello, Debbie. Correct me if I'm wrong. The first question from Debbie is, Debbie mentioned some factors in research in chemistry field. And then she mentioned about human as well, and then other things in doing research and chemistry. How what is the impact of the factors and also in doing research and chemistry, and also okay, that's
okay. Okay, so two questions are related. Okay, so green chemistry, you mentioned that. Okay, so chemistry. Okay, the chemistry.
I'm sorry. I will give a confirmation. What I want to ask is, as scientists, what things should we pay attention to before carrying out development and research in green chemistry? Which do we need to prioritize between short-term needs or long-term energy, nature, human, or emission effect?
Yeah, no. Okay, so, okay, so, okay. These two questions are related. Okay, so I mentioned that there's a lot of chemicals, it produce pollution, okay? So can you stop using some chemical compound or we stop studying chemistry? No, no, no. I don't mean that, okay? Chemistry is really based on, if you want to make battery, all the chemistry reaction is very important, okay? So, for example, like a lithium-ion battery and nickel battery, there's so many batteries, they're all reactions chemistry based. So that means already impact, chemistry already impact to the battery business. That means already influence to the green chemistry and carbon zero. So, I mean, chemistry very important. Green chemistry means, okay, chemistry is very important, but we have to reduce the pollution. So, okay, there's some reactions. If this reaction produces a lot of pollution, we have to modify, change. For example, if we use a lot of sulfuric acid, later the sulfuric acid is very bad for the environment. In that case, we can change to nitric acid reaction. Later, you can produce ammonia, okay? Not sulfate. So sulfate. So if you produce ammonia, you can use some fertilizer or you can use other stuff. That's the green chemistry. And also, you can reduce the organic solvent, chemical solvent. That's the green chemistry. So the same reaction, okay, there's some reactions. If you are thinking about green chemistry, you think about environment and change to the environmental friendly, make some reaction and produce less amount pollution. That's a green chemistry. And also, chemistry really influence a lot already. They make some battery, very nice battery. Okay? So, and also other like sustainable catalysis. That means you can use forever and then you don't produce any pollution. That kind of stuff is the future of the green chemistry. Is it answer for both of you? Okay.
Thank you, thank you. Thank you very much, Professor Kwang Han Chung and Professor Wen Kali. I feel very grateful to able to connect with Professor.
Okay, thank you. Thank you, Professor Lee, also Professor Kevin Young. I think we need one more question. Oh, two more. Okay, two more. This is the last term, yeah? This is the last term of question and answer session.
안녕하세요. I want first of all let me introduce myself. 저는 말이라입니다. I'm from chemistry education. I have question for Professor Lee. In the explanation from Professor Lee, there is an explanation of the competence that we call 4Cs. That is creativity, critical thinking, collaboration, and communication. In carrying out learning, should all four these competence be carried out, or can only 2 or 3 be imposed? Maksudnya, apakah harus semua 4 itu tuh harus atau cuman bisa 2 atau 3 seperti itu? And are there any tips and tricks from Professor Lee for chemistry student here in undergoing learning by paying attention to this competence so that what we learn can be useful later on? Thank you.
Thank you very much. Yes, please.
Thank you for the opportunity. I am Rena Alia Pramestia from Chemistry Education, and permission to asking Prof. Kwang Huan Jun. And I have two questions. The first is how chemistry is used to analyze the environment, impact of biofuel production and usage, including measure greenhouse gas emission and other air pollutant. And the second is current biofuel production technology mature and efficient enough to compete economically with fossil fuels. Thank you.
Is that the question or statement? Sorry.
Yes, the first is how chemistry is used to analyze the environment, impact of biofuel production and usage, including measure greenhouse gas emission and other air pollutant. And the second is question is current biofuel production technology mature and efficient enough to compete economically with fossil fuels? Yes.
Thank you, Rena and young lady with the red scarf. I don't remember your name. I'm sorry. There is three questions. One for Professor Lee. So, should be all be trained? The forces should be all be trained during the class, or we can just like paying a settlement, yeah, one by one or two first, and then followed by the third and the fourth, or should be all trained in the classroom? Thank you.
That is a very important question. To increase the competency of those four C's, the educator need to make special educational material for students, so that in that education material, when students practice those material, that they automatically develop all those four C's. So a lot of effort is needed for the teachers to make the students increase their competencies in all those four C's. Right? Yeah, that would it be the answer? That's educator's responsibility to feel.
Thank you very much, Professor Lee. It should be answer your question, yeah, young lady. Okay, the last question, the last two questions is from Rena for Professor Kevin Young. How chemistry could be utilized to analyze the environmental condition? For example, the level of emission, the concentration of CO2 in the environment, for example. That's the first question. The second question is how biofuel nowadays, Indonesia also produces some biofuels, can compete with fossil fuels, and how both of them are matched or can be blended together and provide us a better energy resources, probably. Yeah, Rena. Thank you.
Okay, so yeah, the global warming, the effect is based on the CO2 concentration and many more methane. Yeah, I mean, there's already commercially available proof that can measure CO2 concentration and methane concentration. Actually, when you check this proof inside, the CO2 is dissolved in water, they produce proton. And then proton, they can measure the proton and then you change the electricity. So they're all chemical based on the proof. So you can easily measure environmental CO2 and then methane. But recently, there is a new project that, okay, so you go somewhere and then measure CO2 concentration here, there. Actually, it's time consuming. So there's a new project that the satellite in the air, and then they can measure the color spectrum, and then they can measure temperature and also CO2 at the same time. So when they rotate, they just measure all the area of the CO2 concentration and then also temperature. It's not done yet. It's a new project. They try to develop like this kind of stuff. So measurement is not that difficult. Okay, okay, that's the first answer. And second one is that, okay, biofuel, okay, and the gas. Okay, I previously mentioned that the Bush, they tried to use the gas to Iraq, and then the Chinese economy boosted up, and the gas price was $100. If the $100 biofuel is cheaper, okay, but right now it's about $30 gas, and then biofuel is already expensive, okay, but okay, gas is really good. I mean, it's easy to use, but we have to think about global warming, future Earth. We have to reduce the CO2 and the other stuff. That's the reason EU and America, they push toward to the less use gas and less use less use some diesel. They switched to the biodiesel, biofuel, and also like the electrical, wind, and other stuff. But so far, economically compare, gas is cheaper. Yeah, the gas is cheaper. Okay. Okay. So that's my answer. Okay.
Thank you, Professor Kevin Young. So, if Professor Young mentioned about EEU, not thinking about IU, yeah, Hanjian. No, not that one. EEU. Thank you for Professor Lee and also Professor Kevin Young for the nice discussion in this seminar. I'm sure that the audiences here in this room also through Zoom learn a lot about chemistry education and chemistry research, and hopefully here all the participants can get more knowledge. Thank you again for Professor Lee and Professor Young, and then ladies and gentlemen, Yorobun, let's give a round of applause to our professor here. Thank you very much. Thank you very much. Ladies and gentlemen, now we have come to the end of this session. I would like to give the time back to Ms. Girindra. Thank you very much and good morning. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Thank you very much, and give applause back to our moderator. Thank you very much, ladies and gentlemen. Now we also would like to present token of appreciations for all of our speakers. Would you please back to the stage? We would like to also invite our Vice Dean for Academic and Student Affairs, Dr. Zainal Abidin, and also Professor Sutikno as our Vice Dean for Partnership Research and also Income Generating to present token of appreciations. Along also with the token of appreciations, we would like to present certificates which will be presented virtually and that you can see on screen together. If no, but we will take pictures together, so don't return to your seat, yeah? Okay, thank you. And I would like to, yes, in the middle of the stage, yeah. And I would like to take photos together with all two speakers of today's seminar. Yes, together. Well, thank you very much. We can also take pictures together here with the participants. Would you please stand up? Okay, so we can take pictures together with the speakers and also vice deans. Okay, please be prepared. Okay, students, could you please come closer so we can take all of your pictures? Maju ke depan sedikit ya, jadi bisa kelihatan di frame semuanya. Mungkin bisa ikut arahan dari fotografer. Oke, yang di pojok kanan, pojok kiri bisa ke tengah dulu. Baik. Mas bisa geser ke depan sini mungkin, Mas. Okay, we'll take pictures, yeah? So, please, we will take a picture. 1, 2, 3, action. Okay. All right, so with the thumbs up or any other styles. Okay, 1, 2, 3, action. Okay, do you want another pose? Okay, it's okay. Another pose. Okay, 1, 2, 3. Yep. Okay, thank you very much, and you may return to your seat. Before we close the occasions, would like you to be here still, witnessing the signing of implementations of arrangement between the Dean of Faculty of Mathematics and Natural Sciences with the head of LUPIC. So please still be seated while the committee arranging the task for the IA signing. Okay, for the first implementations of arrangement signing, would like to invite Professor Won Kohli, Professor Asep Kadarohman, Professor Iwayan Mudarawan, and also Professor Woro Sumani to come to the stage for the signing. We can take pictures together with the documents, yeah, facing the camera. Okay. Let's have a picture together. Thank you very much, Bapak Ibu. The document signs is a proof of evidence of the cooperations between LUPIC, Universitas Negeri Semarang, Universitas Pendidikan Indonesia, and also Universitas Pendidikan Ganesha. We would like to invite the Dean for Faculty of Mathematics and Natural Science, Professor Edi Cahyono, to come to the stage and also to sign the documents provided. Mohon dapat ke atas panggung Pak Agung dan Bu Nani untuk dapat ikut menyaksikan penandatanganan IA bersama-sama. Monggo diaturi ke atas panggung. And also to witness the document signing, would like to also invite Vice Dean for Academic and Students Affairs and also Vice Dean for Research, Partnership and Income Generating to come on stage. Would like also to welcome Bapak Sikir to come to the stage and witness the signing. Would like to also invite all delegates from SOGANG University, Mr. Professor Kevin, also Dr. Suni, and also representatives from UPI and UNDIKSA can join to the stage to have a photo together. Okay, we'll have another photo sessions and now is with the Dean ya. Oke, kembali ke posisi yang tadi mungkin waktu foto bersama. Tidak apa-apa, diulang lagi semakin banyak foto bisa dipilih yang terbaik ya. Silakan berdiri, mendekat. Baik, silakan mendekat, yang tadi masih di belakang bisa maju ke depan, mepet satu sama lain supaya terlihat ya. Monggo. Baik, kita hitung bersama-sama ya. Oke, 1, 2, 3, action. Oke. Mau ganti gaya? Ya, boleh, silakan. Oke, 1, 2, 3. Oke. Oke, give applause. Silakan kembali ke posisinya, adik-adik rekan mahasiswa. Okay, ladies and gentlemen, please may return to your seat. So after this agenda is a token of appreciations for Universitas Pendidikan Indonesia and also Universitas Pendidikan Ganesha given by the Dean of Faculty of the Dean of Mathematics and Natural Sciences to Professor Asep Kaderohman and Professor Iwayan Muderawan. Please for Bapak Dekan, Prof. Asep and Prof. Mudirawan to come to stage for token of appreciation. Okay, give applause for Universitas Pendidikan Indonesia. And another applause for Universitas Pendidikan Ganesha. Okay, thank you very much to come to Universitas Negeri Semarang. Okay, ladies and gentlemen, so this is the end of the functions. Thank you very much for your coming, and we hope the best for your study, students, to graduate on time and to keep working for the best of chemistry and chemistry educations in our country. So, ladies and gentlemen, on behalf of the committee, we would like to deliver also our gratitude to all participants on the Zoom meeting and also all students coming to this event offline today. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya, terima kasih.